AC distribution calculations. Now we will see the individual steps here. Okay. So what are the different steps in voltage drop calculations in AC distribution? Okay. Let us take the first points. First, let us compare the DC and AC. Okay. First point will be point number one. Let me change the red here. Okay. In DC system, in the DC system, the voltage drop is due to the voltage drop is due to resistance alone. Voltage drop is due to resistance alone. But in case of AC system, but in AC system, voltage drop is due to voltage drop is due to inductance and due to R resistance, inductance and capacitance calculations. Okay. Resistance, inductance and capacitance. Next point will be in DC system. In the DC system, all the addition and subtraction of currents, all the addition and subtractions, all the addition and subtractions are simply arithmetic calculations. Are simple arithmetic calculations. Simple arithmetic calculations. But in case of AC system, it is. But in case of AC system, it is vectorial addition. Vectorial addition means magnitude and direction together we have to take. Okay. Vectorial sum. Coming to the third point. The third point will be in all methods are employed for calculating. All the methods are employed for calculating the DC distributors. Is hold good for solving the AC distributor calculations. Is hold good for AC distributor calculations. AC distributor calculations. Okay, but only difference is impedances, currents and voltages will be different. Only difference will be impedances, currents, voltages shall be expressed in vectorial form. Shall be expressed in vectorial form. Okay? Vectorial form. by either current or voltage as reference vector. I'll give you the explanation about this. Okay. Next will be the fourth will be at the load point. At, at the load point, the phase angle between the phase angle, between the voltage and current plays an important role. Plays and plays an important role. So it can be referred in two ways. So it can be either voltage or current will be taken as will be takes an important role will be referred in two ways. First one will be by taking supply voltage as reference phasor, by supply voltage is Vs as reference phasor. Second point will be by taking voltage as the voltage at the load point itself. By taking voltage as the load point itself. Okay. So these are the voltage of calculations. Okay. Now coming back to the voltage distribution calculations. Voltage distributor calculations are so AC distributor. AC distributor. AC distributor voltage calculations. AC distributor voltage calculations are okay. So consider an AC distributor. Let us take an example here. Okay. Let us take an example. Okay. The same way. Okay. So let us take the points. So this will be A point. So let us take this point as B. Let us take this point as C. Okay. So this will be called, this figure is called AC distributor. Figure. So figure AC distributor where this will be called as here. Generally, what we will be doing here, these are the current tappings. Let us take I1. So this will be the I2. But this will be only for DC calculations. If we are doing the AC distributor calculations, then with the current phasor, there will be also a power factor will be there. With the inclusion of this, for current I1 load, definitely power factor will be also there. For I2, definitely there will be cos phi 2 power factor. Okay. Then, if this is the current flowing in this path, then what is the total current here in this section? Outgoing is I1. Then what is the incoming here? I1 plus I2. Okay. Okay. Then what is the incoming here? Out leaving currents at this point. So here it will be simple I2. Okay. So okay. Here the length of the conductor in this section is L1. This section is L1. Length of this section here is L1 and in this section BC is L2. Okay. Then here we will be finding generally resistance of the calculations. So the resistance will be here is, as I said, AC calculation is a combination of resistance plus the passive elements, resistance plus inductance. So if it is the first section, then it will be R1 plus JX1. Then in the second section, it will be R2 plus JX2. As I said, the current sum will be not just arithmetic addition, it will be the vectorial summation. Vectorial means magnitude and phase. J is nothing but it will be acting as an angle of 90 degree. Okay. Now, let us write here. Let us write here. What is the first point we can write here? Is first point is consider an AC distributed system is ABC. Consider AC distributor. Consider an AC distributed system will be ABC. Okay. Next, having a loads of current. Having a loads of currents. What are the currents we have? I1 and I2. I1 and I2, right? What are the terminals we have here? Load points B and C respectively. With the power factors. With the power factors. What is the power factor 1? Cos phi 1 and cos phi. So let us take R1 plus JX1 with the impedance in section 80. Let us write here R1 plus JX1 be the impedance, not resistance here. Impedance in this section AB. Okay. Similarly, R2 plus JX2 be the impedance in this section BC. Okay, hope you understood now. Now let us find the current flowing in the sections. Let us find the currents flowing in the sections are. What are the currents flowing in the section? BC. Current flowing in the section. Current flowing in the section BC is, what is the currents here? I2 in amperes. Then voltage drop in the section BC will be voltage drop in the section. Voltage drop means apply Ohm's law here. Voltage drop in the section BC will be current flowing into resistance in the section. That implies what is the current flowing in the section BC will be I2 into what is the impedance in the section BC? Section BC impedance will be this one. So this will be the Z2. This will be Z1. Okay, to Z2. Okay, voltage at B. Voltage at B is nothing but voltage drop section BC. Voltage at B means apply here similarly. BC means VB minus VC. To find the VBC section. VBC section voltage means VB minus VC. What we require to find? VB. Then VB is equal to VBC plus VC. Okay. Hope you understood now. Okay. So how to find the voltage at B? Voltage at B is nothing but BC voltage plus VC voltage. That implies voltage drop between BC, voltage drop between BC plus voltage at C. Voltage at C. Okay. That implies voltage drop in BC will be this one, I2 into Z2. So that implies, let me change the here. So voltage drop in section BC will be I2 into, what is Z2? Z2 is nothing but R2 plus JX2 plus voltage at C is VC. So that is nothing but VB. Okay, similarly current in the section AC will be current in the section AC. How to find AC? Similarly VA minus VC. Okay, or else current in section AB. Current in section AB will be, you can even follow like this same way. So that implies current in section, okay, let me write here below. Current in section AC, sorry, AB. AB current will be, AB voltage will be VAB is equal to VA minus VB. Now what we require to find here? VA. So VA is equal to VAB plus VB. Okay. Okay. You have to keep remembering this one. Next, voltage at A. Voltage at A will be VA is equal to VAB plus VB. VAB plus VB. Okay. VAB plus VB. What is VAB? VAB is equal to, what is the AB section current? Is I1 plus I2. I1 plus I2. I1 plus I2 multiplied by, what is the value of AB impedance will be Z1 plus voltage at B will be this one from equation 1. Okay, you can even solve the complete value. I1 plus I2 multiplied by Z1 plus what is Z, what is VB? VB is I2 into R2 plus JX2 plus VC. Okay, so that is the value of VA. If you further simplify this, I1 plus I2 multiplied by, what is Z1? R1 plus JX1 plus I2 into R2 plus JX2 plus VC will be VA. Okay, so this will be equation number 2. Now, if we draw the vector diagram with respect to receiving end, what is the first point we have to write here? VC. With respect to what? Receiving end. With respect to receiving end. Here, let us take here. Let us take the points. First one. With respect to the receiving end, what is the first point we can write here? I1 into R1 plus JX1. I1 plus J into R plus I1 into R1 plus JX1. So let us write here. Let us draw the vector diagram. First point. So this will be the I1. So let us write here. Okay. So I1 and I2. Okay. So VC plus I2 into R2 plus JX2. So with this, is, what is the point here we can write here is VC. VC. From VC, what is the next point we can write here? I2 into R2. I2 into R2 will be a line in this way, a line parallel to I2. So let me write here, this one will be, here it is nothing but I2, it is I1. Okay, so it is making an angle of phi 1. Phi 1. Okay, with VC, let us take I2. I2 is making an angle of, this is making an angle of phi 1. Okay, now let us take this I2, I2 as a point, a line parallel to just I2. So this will be the I2 into R2. I2 into R2. Now here we have the J rotation. J rotation means it will be having plus J means plus 90 degree. Minus J means minus 90. I will write here. Plus J means plus 90 degree rotation. Okay, plus 90 degree rotation. Here minus J means minus 90 degree rotation. Now with this plus J, what we can see here, plus J. Now plus J, it is plus 90 degree rotation. So this is so it will be now 90 degree here. So this will be I2 into X2. Okay, I2 into X2. Now the resultant will be VB. VB is nothing but I2 into R2 plus JX2. So the resultant combination of I2 into R2 plus JX2 plus VC. So this is VC. So this is VC. Okay, with the help of this combination, so we will be the vector sum of VC okay vector sum of so this So here is the total combination of, so this will be the VB. Okay. Now what is now VA? VA is a combination of all these three together. Now we will be writing the I1 and I2. I1 and I2 combination. I1 and I2 will be first one into R1. I1 plus I2 into R1. So with this VB as a ground reference, line parallel to just this way. Just copy this one. Okay, line just parallel to. Now here plus J is there. Again, identify the plus J. Plus J indicates what? Plus 90-degree rotation. Okay. Now again, it will be plus 90-degree rotation. Okay. Now this will be VA. And what is this value will be? I1 plus I2, this combination, into plus J, into Jx1. What is this value will be? I1 plus I2 into R1. Hope everybody understood now. So this is the vector phasor diagram. Now what is the combination of I1 and I2 will be? A line just parallel to, okay, a line just parallel to this one, and a line just parallel to, that. So the resultant is called, resultant is the total I1 plus I2. Hope everybody understood. So this is the vector diagram with respect to receiving end. with respect to receiving end. Okay. Hope everybody understood now.